right, so this is one of the most important lessons, I think, in grade 9, and that's piecing everything together when it comes to linear relations. And first of all, we're going to define what a linear relation is. And a linear relation is when you, well, it is a set of points that, when graphed, produce a straight line. It means the entire line has to be straight. There's no wiggles at all. The entire thing is straight. So even if there's one piece that's curved, that means it's not a linear relation. Now, there's two types of linear relations. The first one is direct variation, and that is when we have a, well, whoops, let's get some smaller writing here. It's going to fit it in. Well, that is a linear relation. So it means it's a straight line that passes through point 0, 0, which is our origin. All right, now direct partial variation. Well, it's the other part. It's the other possibility where it is a linear relation that does not pass through our origin, which again is point 0, 0. All right, so if I look to example 1, and I have which type of variation does each graph represent? Well, first of all, again, you got to know where your origin is. And so I look here, and the origin is at point 0, 0, which means the first 0, it doesn't go left or right at all. The second 0 means it doesn't go up or down at all. And so it's right at our starting spot here. And well, in this case, does it, our linear relation, which it is a linear relation, see it's perfectly straight here. Does it pass through point 0, 0? Yes, it does. So that makes this direct variation. All right, B, heating of a chemical. Again, you've got to be able to find point 0, 0. So we start here. There's our origin. We don't go left or right at all. We don't go up or down at all. There it is. Do we have a linear relation? Yes, we do. A nice straight line the entire time, but it does not go through our red dot, which then, of course, makes this partial variation. All right. Try a couple more here. C. Well, again, I'm going to mark my origin. There it is right there. We have a nice straight line here, and it does pass through our dot, our red dot, which is our origin. So that, again, means we've got direct variation on this one. All right, D. If you look at our relationship here, we mark our origin. There it is. Does our graph pass through the origin? Yeah, it does. But hold on here. We have a curve. So this one here, is it direct or partial variation? Neither. Secret C, because this is non-linear, this relationship. And so again, it can't be either, because to be direct or partial variation, you have to be a linear relationship, which means a straight line the entire time.